Good morning, ladies. Today we're going to start a new chapter here, which is chapter 2, and we're going to start with the first lesson we have, which is relations and functions. We're going to talk about what is a relation and what is a function. So we're going to start now. Now, what is a relation? A relation is a set of pairs of input and output values. You can represent as a relation in 4 different ways as shown below. So again, a relation is a set of pairs of inputs and outputs. We can represent them in different ways. Now let's see here. Our first way to represent is ordered pairs. As a coordinate here, we have an x and we have a y. So the x is going to be the input and the y is going to be the output. So if we have these coordinates, it means that this is a relation, this is a relation, this is a relation, and this is a relation. Okay, so this is the first thing, which is the ordered pairs. The second way that we can represent is mapping diagram. This is called a mapping diagram here, when we have these two bubbles, I guess, like input and the output. So we're going to check here how many times -3 is here. Only 1 time, so we're going to write it 1 time. So here, how many times do we have 3? Also 1 time, so we're going to write 3 also. Here we're having 4 2 times, right? So we're only going to write it 4, and we're only going to have 2 arrows going out from it as 4 -1 and 4 3. So again, if here we have an input that's written 2 times, or an output that is written 2 times, in the mapping diagram we're just going to write it 1 time, and we're going to bring from it 2 arrows. Okay, so this is the mapping diagram. Here the arrows show how to pair each input with an output. Now the third way is the table of values. We're going to put the table of x's and the y, as here's the input and here's the output. Now the fourth way is the graphing, when we have to graph on the xy coordinate here. So as if here we're having this graph and we're just plotting -3 with 4, it's going to be -3 with 4, and here we're plotting 3 with -1, and so on. So we're just going to plot the x and y's, like the inputs and outputs. Okay, so let's now start our first problem here. Here, presenting a relation. This is the first problem. When skydivers jump out of an airplane, they experience free fall. The photos show various heights of a skydiver at different times during free fall, ignoring air resistance. How can you present this relation in 4 different ways? So here we're having this skydiver is jumping off a plane, and here they're having a relation of seconds with feet. So here, this is the first relation. With 0 seconds, it was 10,000 feet. Here, 4 seconds, 9,744 feet. Here, 8 seconds, 8,976 feet. Here, in the same 12 and 16 seconds, we're gonna see how many feet for them. Okay, so we only want to represent them. We have, as we said, we have these 4 different ways. So if we wanted to represent them in each way, let's see. Here we're having 0, 10. We're going to say that this is as the x and this is as the y. The same thing for here and here and here. Let's see. Here we're having 0, 10,000. This is the mapping diagram. 0, 10,000, 4. We're just going to put them, and we're going to put an arrow from the input to the output. So here each input has 1 output. So we're just going to put an arrow from the input to the output. The ordered pairs, as we said, is going to be as this relation from 0 up to 16 as the input, and also from 10,000 up to 5,904 as the output. I'm just going to plug them as xy coordinates. Here's the table of values. We have times in seconds and height in feet. We're just going to plug them in the tables. And for the graph, we're just going to plot the points on the graph. Here's the x-axis. Here is going to be the times in second, and here the height in feet. So this is how you plug them. Let's see our second example here. The monthly average water temperature of the Gulf of Mexico in Key West, Florida varies during the year. In January, the average water temperature is 69 degrees Fahrenheit. In February, 70 Fahrenheit degrees. In March, 75 Fahrenheit degrees, and in April, 78 Fahrenheit degrees. How can you present this relation in 4 different ways? So let's see the ordered pair here. We're just gonna plug in. As we're having January, February, March, April, May, and April, from January up to April, this is the input. Okay, so we're just gonna make it as 1, 2, 3, 4. We have here 4 inputs, 4 inputs, and because we're having 4 inputs, we also have 4 outputs here for each input. For January, we have 69 degrees. For February, 79. So we're just gonna put 69, 70, 75, 78. The same for the table values. And here we're just gonna plug these XY coordinates or points. Okay, so that's how we represent a relation. Let's go for the second idea we have here, the domain and range. What is a domain and what is a range? Now, the domain of a relation is the set of inputs, also called the x coordinates of the ordered pair. So again, we have the domain is the set of a relation is the set of inputs, or the x. So here, this is the input, or these are the x, right? The x coordinates. So these are the domain. The input or the x coordinates, it's the domain. Now, what's the range of a relation? The range of a relation is the set of outputs, also called y coordinates of the ordered pair. So again, So again, we have the input is called the domain, and the output is called the range. Or the x is called the domain, and the output is called, and the y is called the range. Let's see some examples for finding the domain and range. Use the relation 0, 10,000, the same as the previous example here. We're just asking for the domain and range. Let's now see. Okay, so let's see here. These are the set of relations. We're going to know what's the domain and what's the range. So let's start here. Let's write first the domain here we have. It's going to be the x coordinates, or the inputs here. So here we have 0. Here we have 4. Here we have 8. Here we have 12. And here we have 16. Let's see the range here. It's going to be 10,000. Here it's going to be for 9,744. Here it's going to be 8,976. Here it's going to be 7,696. And here it's going to be 5,904. So here's the domain as the x coordinates and the range as the y coordinates. Let's check here. The domain is going to be 0, 4, 8, 12, 16. 0, 4, 8, 12, 16. And the range is going to be 10,000, 9,744. And the y coordinates here. Let's see our second example we have. What are the domain and range of these relations? So again, okay, so let's now write the domain here. It's going to be -3. Here it's going to be 0. And here it's going to be 2. Here it's going to be 9. Here it's going to be 23. Let's go for the range here. It's going to be 14. Here it's going to be 7. Here it's going to be 0, -18, and here it's going to be -99. So this is the domain, which is the x coordinates, and the range, which is the y coordinates. Let's check here. -3, 0, 2, 9, 23, -3, 0, 2, 9, 23, and here it's going to be 14, 7. Okay, so these are the domains and the ranges. Okay, let's go for the second idea we have here. What is a function? Okay, so we're done with the relation. We know that the relation, it's the set of pairs of inputs and outputs. Now, what is a function? A function is a relation in which each element of the domain or in input corresponds with exactly one element of the range. Again, each element of the input corresponds with exactly one element of the output. Okay, so now let's see how. Let's say, for example, we have an x. This is the input, let's say, or the domain, and we have it has a relation with y and let's say y node. So it has a relation with y and y node. This is not a function because we said the function when the domain corresponds with only exactly one element of the range. For example, if I had like x with y, then x node, for example, let's say with y node, this is a relation, but this is not, a function. This is not a function because here x, it has it corresponds with y and y node, so this is not a function. Now let's see here an example. In the next page we have, okay, here we have more than one example, identifying functions. Now let's try this one. Here we're having, these are the domain and these are the range. We have -3, it corresponds to only -2, so this one, okay. 0 corresponds with 7, so this is also okay. 4 corresponds only with 1, so it's okay. So this means that each domain corresponds with exactly one range. So each element in the domain corresponds with exactly one element in the range. So this is called a relation, a function, so this is correct. Let's go for the second one here. We have here, okay, just let's draw this as a table, then let's see. Okay, so now I drew them as domain and range. Here we have 4, I plugged it here one time, 8, 1, 6, and here again we have 4, so I'm just gonna write it only one time here. Let's go for the range to see. We have -1, I wrote it one time, 6 one time, -1 again, so I'm not gonna write it again, 6 again, also I'm not gonna write it again, and here we have 1. So now we're going to see each relation. We're going to draw an arrow from each relation to the other, okay? So here we have 4, -1, which is 4 with -1. Just let's put this as O. Okay, so here 4 with -1, then 8 with 6. Let's go with 8 and 6. Okay, just let me put in lines. It's gonna be 4 with 1, then 8. This is also not shown. Then again it's gonna be 8 with, this is not shown. Oh, this is not even changing because, okay, so again we having here 4 with -1, then 8 with 6, then 1 with -1, we have 1 with -1, then 6 with 6, then 4 with 1. So let's see here, girls. It's going to be 4 with 1. So let's see here, girls. Here we're having 4. 4, it gave me 2 range. So 4 is a no for me. It does not make this a function. So from the beginning, all of it, it's not a function. Not a function. This is supposed to be a function. Okay, this is not a function. Okay, why? Because here from the beginning we have 4, it gave me 2 outputs, so this is wrong. But if I had, for example, here, let's see here we're having 8 and 6, they gives me a range of 6, right? When the range has more than one domain, it's fine, but when the domain has more than one range, it's not fine. It does not make it a function. So this is not a function, we said. Let's check here. Let's check here. Each x coordinate must correspond to only one y coordinate. The x coordinate 4 corresponds to -1 and 1. The relation is not a function. So let's go for the third example we have here. We have these domain and these range. We're gonna check. Now from 2, it gives me how many outputs here or how many ranges. negative 3 and 3. So from the beginning, this is not a function, and this was not a function, and this is a function. No, the relation is not a function because the x coordinate 2 corresponds to 2 y coordinates. So now let's go here for the third idea that we have. We're done with the first 2 ideas, I guess, or 3 ideas. Okay, let's go for the next idea here. You can use the vertical line test to determine whether the relation is a function. Now we have this test, which is called the vertical line test. We can use it to determine if this relation is a function or not. The vertical line test states that if a vertical line passes more than one point on the graph relation, then the relation is not a function. So for example here, we have this graph, okay? To know if it's a function or not based on this graph, without like making any other way of to show the relation, we're going to just make a vertical line through it. If it cuts more than one time, if it passes more than one time, it means it's not a function. If it passes only one time, it means it's a function. If a vertical line passes through a graph at more than one point, there is more than one value in the range that corresponds to one value in the domain. So this determines that this function, relation is not a function. Let's go for some examples here. Let's try this one here. Okay, so let's try it here. Let's make it pass over here. Does it pass more than one point here? Yes, here we're having this point. Oops, sorry. Here we're having this point and this point. So is this a function? No, it's not. Oops, sorry. Let me just write it over here. So this is not. What's wrong? Okay, so it means it's wrong again. This is not a function. Let's try this one here. Let me just try cutting it over here, or over here, or over here. Now let's see how many points does it cut. It cuts only here, this point. It cuts here, or it cuts here, or it cuts here. So the vertical line, one vertical line, how many times does it cut? One time. So what does this mean? It means it is a function. Let's try this one here we have. Let me, for example, cut it over here, or here, or here, or here. So let me just check over here. Here it only cuts one time. Here one time. Here we're having 2 times. So obviously this is not a function. Let's check the answers here. This cuts. So A and C, they fail the vertical line test because for each graph a vertical line passes through more than one point. They do not represent functions. Graph B does not fail the vertical line test, so it represents a function. So girls, this was our lesson for today. Tomorrow we're going to continue the lesson with 2 more ideas maybe. And I'm going to give you the classwork, so please solve it now. And at the end of the period, I'm going to upload the solutions for the classwork questions. And have a nice day, girls.